Okay, so the two problems we're going to look at is 50 and 88. 50, first our goal is to solve for the tan squared x term, right? So if we have a variable x, we have to first solve for tan x before we can get the angle. So we need to solve for tangent x first, and it's got a square there. So in order to get rid of the square, we're going to need a square root. Well, first, to get rid of the square root, we have to get this whole term by itself. So we just treat it like a linear equation. We add over 9 and divide by 3. So we have 3 tangent squared x equals 9. Divide by 3 on both sides, so that will give us tangent squared x equals 3. And now if we square root, we just want to kind of be careful with our ratio on the other side first, because of the square root, we get a plus or minus. We get plus or minus 3, which we're going to write as a fraction 3 over 1. So what this is saying in human speak is one angle has a y over x of root 3 over 1. And what I tell my students is we want to look for, particularly if this is a unit circle ratio, which it is, y numerator over x numerator. So we're going to write y numerator is root 3, x numerator is 1, and as we know at the unit circle, it's always over 2. And note I disregarded the negative at this point. We're just trying to get our reference angle in the first quadrant. The first quadrant reference angle that has an x value of 1/2 and a y value of root 3 over 2 is pi over 3. Note this problem is from 0 to 2 pi. So we are doing this in radians. So x is going to equal pi over 3 is where tangent's positive in the first quadrant, or tangent is positive root 3 in the first quadrant. And note, because of the plus or minus, the plus gives us first and third quadrant, because tangent's positive in the first and third. And then the negative gives us the second and fourth quadrant. So we have all pi over 3's in each quadrant, first, second, third, and fourth. So I'm going to list them all in order. Pi over 3 is our pi over 3 in the first, obviously. 2 pi over 3 is our pi over 3 in the second. 4 pi over 3 is our pi over 3 in the third. And then 5 pi over 3 is our pi over 3 in the fourth. And that would be our final answer. Next, we have cosine x equals negative 4 over 7. Negative 4 over 7 is not a unit circle rotation. So we are simply going to use our cosine inverse function in our calculator. My suggestion is to plug in positive 4/9 rather than negative. Reason being is you're just trying to get the reference angle at this point, and then we'll deal with what rotation it truly is depending on the quadrant. So if I plug cosine inverse 4/7 into the calculator and make sure I'm in degree mode, I'm going to round to the nearest degree. It's 55.15. So I just rounded it to 55. That's our reference angle. I'm going to write it like this. Theta sub r, meaning our reference angle. Meaning if this was in the first quadrant, our reference angle is 55. So now we got to figure out what our actual rotations are. Well, we look up here again and we see it's a negative ratio. So we ask ourselves, where is cosine negative? Cosine is negative in the second quadrant and in the third quadrant. So we want a reference angle of 55 degrees in the second quadrant. So now, if this is my reference angle of 55 degrees, I want to figure out what that rotation is. Well, this whole rotation is 180 and I'm subtracting 150. So if I go 180 minus 55, our reference angle, that's going to give us 125 will be our first angle. And then the second one is a 55 degree reference angle in the third quadrant, which would be 180 plus 55. And that gives us, what, 235? So our solution is, was it theta or x? Oh, it was x. And it should have been x sub r, not theta sub r. But hopefully you understood what I was trying to accomplish there. So our solution would be 125 and 235. And then just mind your rounding as far as to the whole degree, tenth, etc.